Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue the load flow analysis for the different cases of the power system we have. So if we open the loading table for any load we have, for example, this is static load, by double click on it, then loading. Here we can suppose a different scenario rather than the design scenario as what we have analyzed before for the power flow analysis, as the power flow analysis was related to the designing case for the designing loads. But suppose now we need to work according to the summer loading condition, so we need to analyze the power flow analysis based on the summer loading condition. And from the nature of the summer loading condition, it may be an overloading case. This is because the summer loads are higher than the average loads of the rest of the year, as the summer loads may contain air conditioner loads or some other loads that increases the overall consumed power by the network. And for this purpose, we can set the loading percentage of this first load at the summer case to be 110%, for example, here 110%, and we press on OK. Then we open the second load, which is this lamped load, and we go to its nameplate. Then for the summer loading, we can set it to be 115%. And OK. Then for the second lamped load, we open its nameplate and we can set its summer loading condition or summer loading percentage to be also 115% and OK. And finally, for the last lamped load, we can go to its nameplate and set its summer loading condition or percentage to be 105%, then OK. After that, and before running the load flow analysis, we need to adjust the settings of the study case. So we can access the Edit Study Case tab, and we can make a copy of this current study case, and we set its name to be Summer Load Flow Analysis, and press on OK. Then we open the Loading tab, and we access the loading category for the different loads we have. And we set the load flow analysis to be at the summer loads. Then we press on OK. After that, we flip to the study case that we have just created by pressing on this tab. Then we set it to be the summer load flow analysis. So we will make our load flow analysis now based on this summer settings that we have set the loading conditions to be the summer loading conditions. And we run the load flow analysis. Also, we can set the units to be the active power and the reactive power. Very good. You can see those are some different results for the active power values and the reactive power values drawn from the different transformers and absorbed by the different loads. This is because we have increased the loading condition at each load of them at the summer case. And for this reason, we can find that the cable cross-sectional area is not sufficient for this cable, while it was sufficient for the previous case. So we have a critical alert here for this cable. Hence, we need to redesign it. We access this cable, and we can set the number of parallel cables to be 5, for example, and press on OK. Then we run the load flow analysis again. You can see we have solved the critical alert for this cable as it's not overloaded now. Also, there is a problem in this transformer, so it has a critical alert. It seems that to be an overloaded transformer as we have increased the loading condition of those loads, so the transformer now is underrated. Here we can open the critical alerts. You can see the transformer is overloaded as it's a 40 megavolt ampere transformer and it operates at 41.4 megavolt ampere. So we can drag this tab down and access the rating of this transformer. Its rating, we can set it to P, 50 megavolt ampere, and okay, we can zoom out a little bit. Then we run the load flow analysis again. And that's it. Here we have no critical alerts, and all of the alerts we have are some marginal alerts or some accepted alerts. So this is the meaning designing the load flow analysis at all of the different cases of running the system, the summer case, the winter case, the shutdown case, as we need to analyze the system at the different loading conditions. You can notice that when the loading condition changes, some of the components like this first transformer and this second cable, they were accepted at the previous case at the design loading condition, while here they are not accepted with their previous ratings at the summer loading condition. So we will have to adjust them to cope with the new overloading case, which is the summer case. More than great. So that's about this tutorial. Hope that's clear right now. Thank you for watching and see you next tutorials.